All right, Algebra 2, we have 4.4 today. We're finding the least common denominator or the least common multiple, whatever you're used to. Then just some addition and subtraction with fractions, and we're going to multiply some complex fractions as well. So our first task is to subtract these two fractions right here. And it's kind of tough. Because we need to look at the denominator, and that's different than what we're used to. In this case, we have the same denominator, so not as much work. We're just going to combine them. So y squared minus 100, we put that on top, because since we have the same denominator, we can just keep the same, almost like just a normal fraction. If we had 2/5 plus 1/5, it's the same type of idea. But here, we need to simplify, and we can factor that down into a y plus 10 and y minus 10. And then on the bottom, both of these have y's in common, so let's pull a y out. Before we cancel, we're going to find our restrictions. So y can't be 0 and it can't be negative 10 because the bottom of a fraction can't be 0. But then we are able to cancel these y plus 10s, and we're left with y minus 10 over y. Now here's a case where the bottom of the fractions, the denominators are not the same, so we need to find the least common denominator. And if you need help finding the least common denominator, there is a YouTube video that you can watch for extra help. So here we have 7x over x squared minus 9 minus 6x plus 1 over x squared minus 6x plus 9. And let's factor out the bottom of both of these before we find our least common denominator. So we have x plus 3 and x minus 3. And over here we have x minus 3 and x minus 3. So in order to find the least common denominator, we need to include everything that both denominators have. So we have an x plus 3 over here, so let's include an x plus 3 in our LCD. We have an x minus 3, so let's include another one. And then over here we have another x minus 3, but it's the first one that we've seen in this new fraction, so we've already got that covered right here. But then we have another one, so we have to add a second. So basically what this is saying, the LCD is saying that between these two fractions, they both have at least one x plus 3, and then at least two, or at most, sorry, they have at most one x plus 3, and then they have at most two x minus 3s. So then looking at these, this blue over here is the same as this red. What is this denominator missing from the least common denominator? Well, it's missing another x minus 3, so we need to multiply the top and bottom. And over here, what is this denominator missing? It is missing an x plus 3, so let's multiply that by the top and bottom. And then from here, we are just distributing. And then over here, we are foiling, so it's distribution again. And then we're just going to distribute this subtraction sign. So all these positives up here become negatives, and then we're going to combine our like terms, and we see our answer right here. And if Savas is particular, we would have the restrictions -3 and +3. Here we have a complex fraction, which means we have fractions on top of fractions. Up here on the top, we have 6, which is really 6 over 1, minus 11 over x. And then on the bottom, we have x over 1 plus 7 over 8x. So our denominators are 1x, 1, and 8x. So our least common denominator would be 8x, because 1 you could multiply into 8x, x you could multiply into 8x, 1 you would multiply into 8x, and obviously 8x is itself. So we found that least common denominator, so we're going to multiply the top and the bottom, and we're going to cancel all of our denominators. That's the goal. So we're just going to distribute in here, and we have 48x minus 88, because this 8x, the x cancels with the x, and then we just multiply the 8 with the 11. 8x times x is 8x squared, and then this 8x cancels with this 8x, so we just have 7 left over. And then lastly, we have 8 in common between the 48x and the 88, so let's pull that out, and that's our simplified answer. In our last example, we have another complex fraction on top of a fraction. So before we get to work, let's factor all of these down, and you can see that factored form right here. But remember, Fractions are division, so let's write this as a division problem. So the top right here divided by the bottom right here. And then if we remember from maybe it was 4.3, when we divided by fractions, we can actually just flip it to multiplication and then flip the second fraction upside down. So once we have done that, then we can just cancel anything on the top and bottom. So like, for example, we have 8x plus 8 and x plus 8, x plus 6, x plus 6, x minus 9, x minus 9, and what's left over? X minus 6 divided by x. This is a lot of factoring, and it's a lot of multiplication and just distribution. So if you do need help, or if you're getting tripped up by a problem over and over, please reach out. Do not try it a million times.